everyone. This is Wei Hao, and I want to present our works along with my student Jack from the Department of Computer Science and Software Engineering at Monmouth University. And our work is about static over approximate detection tools for at-risk DLLs. Dynamic link libraries, short for DLLs, are files that contain code and data that can be used by multiple programs simultaneously, which made DLLs an essential component of the current Windows operating system. And the DLLs have many benefits. First one is modularities. DLL enables modularization of the code, which means a large applications can be broken down into smaller manageable parts and can be developed and updated independently. Another benefit is DLL promote code usability because commonly used functions and some procedures, they can be stored into one DLL and then they can be reused by different applications at the same time. And DLLs also help in efficient memory management, which means multiple applications, they can share the same DLL, which will save a lot of memories. And also with DLLs, update will be more easily. For example, if the one DLL is updated, all the applications that use that DLLs will benefit from this update, and without requiring the change to the application themselves. And the DLL has a wide range of applications in realities. For example, like in system libraries, in game development, in interoperabilities, security tools, or broad extensions, and many other different areas. In system libraries, currently, many core functionalities of the Windows operating system, they are implemented as DLLs, so it is widely used. For example, the Windows APIs itself, it is provided through a series of DLLs, or more functionalities handling files, the graphic things, networking, and more, they will be available via DLLs. And even in third-party libraries, many of them and frameworks, they are distributed as DLLs across Windows operating system. And these libraries, they provide additional functionalities such as database access, the user interface components, and graphic renderings, and other many different functionalities. Also, DLLs can be used as plugins and extensions. For example, many software applications now they use DLLs to support their plugins and extensions, web browsers, the graphic design softwares, and some IDEs. For example, VS Code, they allow third-party developers to create extensions, the latex extensions for VS Code and some others, and they are loaded as DLLs. One good thing about DLL is its interoperabilities. For example, it allows people to write between different programming languages. For instance, a DLL, it is written in C++. They can be used in different applications, in a net application or Python script. So that really make DLL useful in the real life. Also, in game development, DLL is used a lot because they can be used to modularize the game engines and handle graphic renderings, physics calculations, and manage the audio part and other things. And this modular approaches provided by DLLs allow the game developers to update and optimize their individual components without affecting the entire games. That really like improved efficiency. And also in the security areas, like some security tools, they use DLLs to inject code into the running process so that they can monitor and protect the programs, the computers. For example, sometimes DLL is used in the antivirus software, and it will help the software to hook into the system process to try to detect, to monitor, to prevent malicious activities. And also in the enterprise applications, they have shared libraries using DLLs. For example, like in Google, you see they have Chrome, they have Gmails, they have like a Google Cloud and many things. And interpreter applications, they will like use a set of DLLs to handle the common business functions, logging, authentications, and data data processing. So which will really reduce the development effort and ensure the consistency between all the different products within the same enterprise. Also, we may do that many times in the browser extensions like Chrome, like Firefox. They use the as to load extensions, and these extensions add new functionalities to the browsers, like the ad blockers, the password managers, and the custom themes, and many other like different great features they are used as DLL. However, there's some risk about using DLLs. So DLL injection is one technique which is used by both legitimate softwares and also malicious like adversaries to run some code within the address space of another process by forcing it to load a DLL. And there are a few like common steps for DLL injections. Like first is try to identify the target process. So the attacker will try to identify which process the DLL was injected, and this is usually done by obtaining the PIDs process identifies. And then after that, it's trying to allocate the memories in this target process and trying to like find some space to hold the path of the DLLs that will be injected. Then it will try to write the DLL path to the allocated memories. After that, the important part is we'll try to create a remote thread in this target process within the entry point set with a special function called the load library function. And this load library function will be used when this thread is executed. These DLLs will be loaded into this process by this load library function. After that, this DLL will be executed after it's loaded, and the code inside this DLL will be like executed inside the context of the target process, which means the adversaries can put some malicious code into this DLL, and then it will be executed. In this case, like depending on the code the adversary put into these DLLs, there are some malicious use of the DLL injections. For example, like the key logging and the data set, and the adversary they can use DLL to load the key loggers into some valid legitimate process to capture some sensitive information, some password, credit card information. And also it can be used as a privilege escalations, like by if we can inject DLLs into process with higher privileges, and attackers, they can escalate their privileges on the system, gain the admin right. Also, like DLLs, they can ensure persistence by loading themselves into process, which will start automatically with the system, like the explore.exe, and then every time you have your system, this piece of code will always be like executed. And one use case for the adversary to use DL injection is to bypass the security. So, for example, like the antivirus softwares and firewalls, if the adversary can run some DLLs inside the antivirus software or firewall, then they can run the code within the trust process. Another case is malware, and the DLLs can be used a lot to spray malware and to propagate itself by injecting copies of code into other running process. And it will be harder to detect and remove. There are some common techniques for DL injections, like create a remote thread and load libraries as we already introduced. It's the most common way by creating a remote thread and use a load library to load the DL. And some people also have, like some adversary, use manual map, which instead of using load libraries, they manually map the DLLs into the target process memories. And another way is called set window hook exercise, which use a Windows hook to load a DLL into a target process. And when certain event occurs, like such as keystroke or mouse movement, then this DLL will be executed. And another way is called reflective DLL injections, which load a DLL from memories without using the Windows load. And this one involves writing the DLLs into the target process and manually executed it as an entry point. And there are some characteristics of this method, like for example, manual mappings. It really gives the adversary the complete controls and bypass security, and it has DLC operations. And the standard create a remote thread is a simple implementation, and it can be detected by security solutions. The set Windows hook accessor is hard to detect, and it will intercept the sensitive data and app initial DLLs. This way will increase attack surface and persistence. There's some real-world examples using DLLs. For example, like the WannaCry, ransomware, and Mimikatz, emotive shortens, and the backdoor. And today, our objective of this tool is we're trying to early detection of potential risky DLLs before it will be loaded. And so that we try to do that, prevent the DLL injection by performing frequent security checks. And what we do is we try to have a static detection tools called SDDs to static detect of potential risk DLLs, and we rely on the file integrities to check and identify the temporary DLLs. So first thing we would need to identify is what is the potential risk DLLs. So for example, for Windows application to use some DLL, it will first search in the expected locations of DLLs, for example, System32 in the Windows file system. And if this DLL is found in the expected locations, this application will use it. Otherwise, if it's not found, this application will then search for other alternative locations where this target DLLs might be stored. And let's think about if we have application 1.0, its original version, and if this DLL-D is not found in the default location, and then in its updated version, like app 2.0, the use of DLL is now found in the default location, which means this update of this app from version 1.0 to 2.0 on these machines will introduce the actual use of this code of DLLs in the default location, which means we think it might be potential risk because some adversaries may put this like a malicious code and put it into the default system32s of this application on these machines for this application. And to do that, our tools, like it is overview of our tools, and it has two phases. The first phase is trying called the DAR directory analysis. It's trying to analyze the software and figure out all the DAR used and if it appeared in its correct locations. And the second phase is called at-risk DLL detection. We're trying to use the information in phase one and then trying to compare it with the latest versions of the software to see if there's any flag of DLLs that change the locations or and then which we think is risky. And the first one, phase one, we will analyze the targeted application DLL usages, and then we're trying to generate a report with a true list and a false list of DLLs. And the true list contains all the DLLs that is found in its default location, and the false means it's not found in the default locations. We'll also record the timestamps so that we can compare with different versions according to the time. And this we have a direct analysis algorithms, and this algorithm takes the executable passes, and then the output is the analysis report, which is the true list, false list, and the timestamps. Here we use a P5 software to list all the DLLs, and then we'll check its locations, update the list. And this is the algorithm, and which can be found, detail and explanations can be found in the paper. And after we perform the algorithm one, and we do phase one, generate the report of the DLL usages of the previous versions of the software. The second phase is called at-risk DLL detection. It will compare the current DLL usages with the historical one generated in the phase one. And then we're trying to identify the DLLs which have the changed locations and flag the potential risky DLLs. And this algorithm, we have an algorithm called the at-risk DLL detector algorithms, which has a few steps. Its input is the executable paths, previous times, and the libraries which store the analysis report of these softwares, of many different common use softwares of its previous versions. And the output is the detection results, a list of at-risk DLLs. And the key point is we'll compare the current and the historical DLL usages. And this is the algorithm details. And our implementation, we implement in the Python, this tool in Python, and SDD is available on GitHub, and we're trying to check it. And we also have some further improvement planned for these implementations. To conclude, SDD is provider of approximate analysis of potential risky DLLs and enhance the system securities by identifying the suspicious DLL usages. And we also are trying to potentially integrate it with some antivirus softwares. And we're trying to improve our development by enriching the libraries applications and with more and more softwares, and it's more and more different versions. we try to automating the tools like running schedules so that it can be like run maybe every week, like to try to protect your computers, to give you some warnings about some common update, may introduce some like risky DLLs. And we are also checking update from the application sources. Finally, we're also trying to develop web applications with user-friendly UIs so that you don't need to install it and you can just check it online. And thanks everyone for attend this presentation. And thanks so much. And we are here for questions and discussions, and feel free to contact us.